In this video, I'm going to quickly walk through the physical connection that I am using to get my 1602 LCD connected. So on my schematic, you can see it right here, and I'm going to connect it to this PPI1, and I'm going to call this PPI1. I also have PPI2, and since I was connecting PPI1 and most of the connections are the same to go to PPI2, I just connected PPI2 at the same time. And if I look at PPI1, let's just maybe focus on that, and we can look at the differences for this other PPI here in a minute. What I need to get connected was my ground. So I've got my ground there. I've got my power up here, my VCC. I need to bring in data lines 0 through 7. So I had to tap into something there for the data lines. And what I essentially did is I just used this pin header. Previously, I was pulling the address lines from the left side of this bus header to go to my PSOC for address decoding. Well, the data pins were wide open, so I just simply grabbed, again, these little adapters I've been using. I cut these two size, and I soldered in my 8 data lines into the connectable pin header, and ran those data lines over and jumpered them down. And you'll see that I've jumpered most everything down to the other PPI. As I work my way around, then maybe I'll come over to some of the control signals. Reset, and the reset was just coming out of this chip up here, which is my clock generator. And then I need an IOWC and an IORC. That's basically, am I doing an IO write or an IO read? Different than a memory write or read. I'm going to have to use it. There's, I think, 4. Maybe there's more than that, but there's, I think, 4 actual opcodes I can use in my assembly to say I'm doing an IO write or read. For example, in and out are 2 of the examples, and I think there's a couple others that I haven't looked into yet. But I'll use the out and I'll use the in, and then I can work within this 64K region that's specially set up for IO addresses. But I need to get this IOWC and IORC, get those signals in, and those are coming from the bus controller. So from the bus controller, I brought those over. And then I also needed to have a chip select, and that is what is different between these 2 chips. I think everything else is pretty much the same as far as what's coming in. IOWC, reset, IORC. I've got my data lines the same, and both will use the same address 1, address 2 coming in. This one is a PPI2 chip select latched, and the other one is a PPI1 chip select latched. And those I am pulling from a latch, hence the name I gave it, and that will be this control latch here. So previously I've been using these bottom 3 latches for the address latching. Now I'm starting to use this latch here, which is a 74573 latch, and I'm bringing in this PPI1 chip select, PPI2 chip select. I'm latching it and sending it out as a latched version of that. Well, that latched or the unlatched version, what's coming into that is coming from my PSOC. And so within my PSOC, I've had to put in support that at a certain address on my address bus, I'm going to go ahead and send out this chip select, basically. And what I've got for that at the moment, I think I've got it open. Let me get over to it here. Really what I'm just trying to do is look for certain addresses. And in this case, previously, if I zoom out just for a second, I've been using these different inputs to do things like my ROM output enable in the upper right, my RAM output enable. And then I also need to do address decoding to find out when should I basically enable this chip. And I've got these 2 sets down here, and this is where I'm starting, and I might need to tweak this as I get into this, but this is what my initial thought was, is that for the first one, PPI1, I'm going to give it a base address of E0. PPI2, I'm going to give an address of E8, and this decode should, I think, get me what I'm looking for there. So when I go to do an IO write, I can do an IO write to E0, and it should get to PPI1. And if I do an IO write to the E8, and the following bits that would increment that for both of these. But this would get me to PPI 2. And if I come back here and I look, and I'm sending those out into the latch and then into my actual PPI. Now, it's not just the bus, or not just the address from the bus that's going to give me this, what I need to know. There's also this IO read or IO write. So one of those will have to tell me that I'm actively reading or writing. Plus, I'll have to have the chip select for this specific IO device. So every IO device will need its own ranges of addresses within the 64K range, I believe, that I have to work with. And I can go back to the data sheet for this and double check somewhere in here. I believe it mentions a 64K range. And see if I can happen to find it quickly or not. Here, IO space. So the IO space consists of 64,000 8-bit ports, and then it says F8 through FF are reserved. So let's just make sure I'm not using those. If I go back here, I'm doing E, so I'm in the E range, so I'm not using what's reserved, this F8 through FF. I think, and I'll get to this at a later video, I think the math coprocessor is what's using that, and that's how I've set up my decode for my math coprocessor. But I'm several videos away from, probably a dozen videos away from getting to a math coprocessor. I want to get my PPIs working, then I'll get to interrupts, and then eventually get to this math coprocessor. But I think that is going to give me what I need to come in and tell me that I have a read or write, and is this the IO device that should be active or not. And so all of those signals have been run. I've come from my PSOC down to the latch in, latch out, into those appropriate chip selects. So address information I'm pulling from this pin header, and I didn't actually wire those in yet. I'm pretty sure, and based on feedback I've gotten from some of you, I should be using A1 connecting to my A0 and A2 to A1. And so I'm just going to make sure that is working as I want it to. And then once I confirm that that is the right configuration that works for this, I'll then probably tap in down here. I'm not going to waste a pin header here on the bus board for 2 addresses. I want to leave that open for something that's going to take advantage of the whole thing. So I'll bring down those 2 addresses from down here up, and then I'll jumper them up and get rid of these temporary ones. I think that is about it for this. You know, that the set of connections isn't too bad to get into the PPI. Now to come out of the PPI then into my LCD, I'll just show you what the LCD has for now. You know, I do have my VCC and a ground, and then there's this pin 3 that goes to this trim pot so that I can adjust the brightness of the screen. In previous videos or pictures, you probably saw I had this over here. It was just kind of in the way, so I moved it over to the right and ran that wire over here down to ground. And then I had to bring over my 8 data lines out of my port, and so I'm using port A. And basically port A line 0 is going to go to DB0, and then just work my way around this chip for the rest of those data lines. And then for these 3 control lines, RS, RW, and E, I'm just going to use these bottom 3 control, basically these bottom 3 pins for that control. So this is port B, 0, 1, and 2. And that's it. Later, I will come down to PPI 2 and try to get this PS2 keyboard interface working. So we'll see how that goes. And I think as I look at it, I might be shifting some of the stuff over a little bit because I've got some surrounding components. You can see down here resistors and I think I got capacitor, and there's a diode in there somewhere. Yeah, right here. So I'll have to make some room for that stuff. So this may shift a little bit, but this board will take care of PS2. This board will take care of my LCD, both going through PPIs, and the code will sit on these ROMs. So I've got programming work to do next. Before I talk about that, let me just actually get some power over to my power board up here and turn that on. And I just want to make sure that my previous code from the last video is still working. I haven't broken something in the process here. So expectation is it did its jump, I can tell that, and then I'm going to look for the F0, F0, and it gets in a loop where I should see that F0, F0 come up regularly. So now I can tell it's in the loop. This is like watching the Matrix and trying to read the screen. I've seen this enough. I know what pattern I'm looking for. And there's my 0F, 0F, not F0, F0. So 0F, 0F, that was what I'm looking for. And I've got those, and that all seems to be working still as expected, the best I can tell. So I'm going to wrap this video up at this point, keep it short, but I thought you'd be interested in just kind of seeing what I've got run so far. I tried not to make a huge mess as I went through that as far as wires, and I think I'm doing okay. Every video, the wiring just kind of continues to stack, but I think I'm still sitting in a pretty good spot that I can get things run around. And luckily, all this initial work is very, very solid. This isn't moving. It's not gonna. These pins aren't coming out. It's something I can work around and not worry about pulling out any of these pins. Unlike some of this stuff where I'm just using the native breadboard and wires right into the breadboard without these adapters I've been making. And I can already, I already have to do some adjustments just to make sure these wires don't sneak their way out. So that's the benefit of these little adapters I've been using. But I think I'm good. In the next video, I will get in and try to code this up, and we'll see how that goes. In a video quite a ways back on my build number 1, I was controlling an LCD. I wrote the code for that. Basically, I ported the code over from Ben Eater's 6502 LCD work that I had then later put into my 6502 and 65816 builds. This code that I'm going to use on this, though, is going to be different because on the last one I went straight off of the processor's basically data and address lines, and I went through latches and a transceiver to get to the LCD. Here I'm going through latches and a transceiver, transceivers to get to the PPIs to get to the LCD, and one PPI specifically. So it's a bit different setup. I've got to work with the PPI and work with this I/O writing and reading from it. And I've got code that'll be a little bit different than I used with my build number 1 for the LCD. And I'll have to see if I can get that working, and then I'll kind of walk through what that code looks like. So that is it for this video. Next video, look for some assembly work, and hopefully I can work my way through that okay.